The question is, we have to explain what is observed when a beam of light is passed through a colloidal solve. Okay. So the answer is, when a beam of light is passed, the scattering of light is observed. What is observed? The scattering of light. Okay. So it is very easy. We all know the term scattering of light, which is known as Tyndall effect. This is a very important point. It might come. What effect does uh, colloidal solve experience when a beam of light is passed through them? So we have to write Tyndall effect is shown by the colloidal solve. The colloidal particles size, which is in the range of wavelength of the light, scatters them in all direction. So another important point is, the size of the colloidal particles has to be in the range of wavelength of light. Okay. So if the wavelength of light and the size of the particle of the colloids are very different in magnitude, then it will be very hard for scattering of light to be observed. So the colloidal particle size of the colloidal particles and the wavelength of the light has to be in nearby range. Okay. The second part of the question is, we have to explain what is observed when an electrolyte NaCl is added to hydrated ferric oxide salt. So first of all, what is the example of, one second, what is the formula for hydrated ferric oxide? Basically ferric oxide is Fe2O3, Fe2O3, and since it is hydrated, it has some water of crystallization. Okay, so I will write it XH2O, the Fe2O3 dot XH2O. Okay, it is reacted with sodium chloride, which is written as NaCl. Okay, so now we are going to the answer part. It is showing that the salt gets precipitated because of the neutralization reaction. The ferric oxide salt is positive in nature and we get chloride ion from NaCl. So what does this sentence mean? It means that this ferric oxide, this term is basically positive in nature. Positive. Okay, it has a charge positive on it. We know that NaCl is composed of Na plus and Cl minus. So since this salt is positive in nature, it needs some negative charge to get neutralized. Okay, so Cl minus from the compound NaCl goes into this and reacts with this ferric oxide salt, so that this ferric oxide salt gets neutralized. Okay, so we know that ferric oxide salt is positive and we get chloride ion from NaCl. Moving on to the third part of the question is, we have to explain what is observed when electric current is passed through a colloidal solve. Under the influence of electric current, the colloidal particles start moving towards the oppositely charged electrodes. So why do we observe this type of behavior from the colloidal particles? So you need to know that colloidal particles have some charge. So since they have some charge, suppose we assume that colloidal particles have positive charge. So they will move toward the negative electrode, negatively charged electrode. And if the colloidal particles have negative charge, they will move towards the positively charged electrode. We all know this. Like repel and unlike attract. So I will write colloidal particles have charge. Pardon my handwriting. Okay, moving on.